Thank you very much, Chris. Good morning, everyone. Today we're going to be doing an introduction to Capacitor. The slides are over in the Capacitor webinar section, and I'll be running through those. My name is Jack Samplin. I'm a developer evangelist and sales engineer over here at InfluxData. I'm also running our community site, community.influxdata.com. If you have any usage questions, monitoring, time series related stuff, I would encourage you to drop by and ask a couple of those. Anyway, let's go ahead and get started. So goals for this training, I want to explain sort of how Capacitor works under the covers, what it's doing computationally when it's generating these alerts and crunching these data streams. We want to review tick script syntax. So as many of you know, if you've done any work with Capacitor at all, you have to write your alerts in this custom DSL called tick script. It can be a little bit hairy for people, but we're going to walk through the basics and hopefully get you a better understanding of that. We will also run a Kapacitor instance and then create a tick script and run it on that. And then at the end of the class, we'll talk briefly about user-defined functions, which is one of the more exciting features of Capacitor, which allows users to bring their own functions to do computation on some of these data streams. So machine learning algorithms, that kind of thing. Okay. Capacitor is a time series data processing utility. The title on this slide is slightly off. It's a time series data processing utility. It allows you to process data in streams or batches. So if you're familiar with other similar tools, Capacitor does allow you to act on data that's streaming into the platform, and it also has some tools to go out and grab some data. So kind of ETL related tasks also work in Capacitor. And then these streams and batches of data, Capacitor allows you to trigger alerts on those based on dynamic criteria. So let's say you want to alert if a certain stream gives you a value that's 2 or 3 standard deviations away from the moving average for the last 100 values. Those kind of expressions you can easily write in tick script. Tick script also uses InfluxQL to help you manipulate this data. So the same language you're familiar with in Influx with the query language and that very SQL similar language, you also write in Capacitor. The primary way Capacitor gets data into itself is through subscribing to data incoming to an Influx instance. So the way that works is when you start up your Capacitor, in the configuration file, you would point it at an InfluxDB instance. And right when the Capacitor first starts up, it's going to reach out to that Influx instance and say, hey, I'm a Capacitor. I need to subscribe to the points, the data that's coming into you. And Influx will ship any incoming data in real time over to that Capacitor instance to allow for alerting. And then also, Capacitor can write data back into Influx. So many of you might be familiar with continuous queries. If your database becomes too large and continuous queries are generating a ton of load on your system, one way to offload that would be through use of Capacitor. So those are the primary uses of Capacitor. Oh, something I didn't mention earlier, if you have any questions, please drop them in the chat or Q&A section, and I'll be happy to answer those. So these are, looking back at sort of what Capacitor does, these are the key capabilities. So alerting and processing, or ETL. So obviously alerting, taking proactive steps based on metrics coming out of your system, auto scaling, alerting team members, sending messages to other applications based on data flows, those kinds of tasks, or what Kapacitor was designed for. But because all of this tooling can also be used to write data back into the database, it does excel at processing the ETL jobs too. Written in Go, it's very effective on multi-core systems, and actually can handle quite a bit of load. So if you're looking at our full stack of products, where does Kapacitor fit? You might be familiar with things like Boson or Grafana alerting. There's a number of different products out there. So if you're going to put the full stack together, how does it look? Well, at the center, you have InfluxDB, which is the data store. You've got data flowing in from Telegraph. And then Kapacitor kind of sits there off to the side in a little loop, receiving that data that's coming in from Telegraph, potentially writing back to the database, but also kicking off alerts. And then the last piece of the stack is Chronograph. If you're not familiar, it's a product that we currently have in beta. And there is a user interface for writing Kapacitor alerts. So that allows you to set error bars on a visual graph, and you don't really have to write tick script. That's generated for you. So if you're having trouble with tick script, I would highly suggest you check out Chronograph. So design of the program itself, there's two pieces to it. There's a daemon and then a command line interface that drives the API on the daemon. So each of the Kapacitor list task calls has a corresponding API endpoint, and the CLI just interprets those responses and makes them more human readable. The daemon is where most of the work gets done. It's got the configuration for subscriptions, which Influx instances, which services are we going to report to, PagerDuty, VictorOps. Maybe we're going to send post requests based on this data, or other outputs to writing back to Influx. All of that's configured on the daemon. The tick scripts are held in the daemon store to allow it to alert on that data. And you use the CLI to make any changes to the state of the Kapacitor daemon. And the big concepts within Kapacitor itself are tasks. So a unit of work. That's what you define when you write a tick script. There's a couple of different types that we talked about earlier, streaming or batch. So as I said, streaming will work on the stream of data that's coming in. Maybe you're windowing it into minute segments and doing some sort of calculation there. That would be a streaming task. And then a batch task, it's going to query the database, pull the data back, work on it, and then perform an action. And tick scripts, which we'll talk about in a second, are an example of a directed acrylic graph. And that's how the data flows through these computational nodes. Another important feature of Kapacitor is recordings. So this allows you to record a stream for a certain period of time and replay it back into Kapacitor to test tasks. So let's say you have a certain data set that has an anomaly in it, and you're trying to test a function that you've written to see if it picks up that anomaly. That's a great use case. Or just some normal usage data, and you want to make sure that your thresholds aren't being triggered frequently so that your team's getting alert fatigue. Obviously, having tons of alerts on PagerDuty makes people not want to check their phones. Any questions or comments so far? Okay. So the computational model in Kapacitor is a directed acrylic graph. And this works for both streams and batches. Now, if you imagine at 1, that's where your data is coming in. And then each statement in the tick script creates a new node where that data will flow and then potentially branch off into other nodes based on different criteria. And then at the end, we kick out alerts. There's a result of the computation. And it's important to sort of understand logically that there's data flowing through nodes and then some sort of result with Kapacitor, because it really helps with debugging. Kapacitor show, if you're looking for details on a task, gives you quite a bit of information. It in fact gives you a little representation of this directed acrylic graph and how much data has flowed into each part of it. That can be extremely helpful, especially with some larger tick scripts, some more complicated jobs. If you have a flipped greater than or equal to sign, that'll become immediately apparent by the amount of data that's coming through different nodes. So important to understand. You don't have to understand it too deeply, but just remember that the computational model is data flowing through nodes. So the primary difference here between batch and streaming is up at the top. Obviously, you got batch and stream. In the batch tasks, and let me back up here. These are examples of tick script. So very, very simple examples of tick script. It was designed with sort of a JavaScript-esque method chaining in mind. So that batch task, we're going to pipe to query this data. We're going to work on in a certain way, and very similar with streams. So in the batch task, so in the tick script syntax here, let's dive into it a little bit more deeply. You can declare variables. Obviously, we're calling requests our measurement, and then you can use that down in your tick script. We're going to first say this is our data coming from this stream. So if you think about all the data coming in Influx, maybe there's multiple databases, multiple retention policies, a lot of different measurements coming in. What we want to do with this particular tick script is take a piece of that stream and kind of peel it off and work on it individually. So we're going to say from our requests measurement, and then we're even going to write a where clause down here where isop equals true and value is greater than 500. So in that measurement, this tells me there's a field called value, and then there's either a field or a tag that's a Boolean. Now, you'll notice this does look very similar to InfluxQL. So select measurement from, select stuff from this measurement where, and then we give some conditions there. And then finally in this stream task, we're going to window. So we're going to store up in memory 5 minutes of data and do these computations on it. So we've stored this data stream, these windows, in this data variable. And then down here, we're going to do 2 different things with it. So if we think about that directed acrylic graph model, this node is going to split off into 2 nodes. One of the nodes is going to count the number of points that match our criteria. And then the other one is going to take the average of them. So we care how many are coming through with this Boolean check. And then we also care what the average value is of these high value points here. And this tick script contains examples of all of the different literals that Kapacitor supports: Booleans, numbers, int64 or float64, strings, and then also time durations: nanoseconds, milliseconds, seconds, minutes, and hours. We also have statements. So from variables, data measurement, and comments. you can see the JavaScript-esque double slashes. So that was just a stream node. Now, if we're looking at a batch node, it looks very similar, but just a little bit different. You've got, instead of peeling off a piece of this stream of data that's coming in Kapacitor, we want to select a very specific piece of data from an existing database. So with that, we're going to write a query, and this is just InfluxQL right here. So we've got select mean value from this CPU usage measurement, and then we're adding one where clause. Once that data comes in, and then down here, this period directive tells you how often to run or how much data to pull back. So that would be where time is greater than now minus 1 minute. You could also add that in the query. And then every 20 seconds tells you how often to run this query. So we're pulling 1 minute of data every 20 seconds. We're going to group that into 10-second buckets and also by CPU. So we want to alert if any of the individual CPUs in our machine is going over a certain threshold, or maybe we're doing a moving average kind of thing. So this is a much more simpler directed acrylic graph, but it is still, there's a batch node, it's the initial node, and then we're doing stuff beyond that. And each one of these is an additional node in that directed acrylic graph. Any questions? Okay, so we've been over one stream task before, but let's just walk through it one more time. So the first node is stream. And from that stream, we just want stuff from the database MyDB in the retention policy MyRP called myMeasurement. So we're peeling off a piece of that stream coming from the database, and then we're applying a filter here. And then finally, we're going to window the data after that. And that's a common pattern for stream nodes in stream tasks. You're going to peel off a piece of the data, and then you're going to do some sort of computation on it. So looking more deeply into the stream task here, the window node holds a certain amount of data in memory, and then once that period of time has elapsed, performs work on it, and then outputs results. So it sort of takes that stream and turns it into quantizable units of work that act more like batches and are easier to reason about. So the period specifies the amount of data that will be given to the pipeline. So that 15 minutes there, we're going to be holding 15 minutes of data in memory to perform operations on. The every specifies the frequency at which the data will be yielded to the pipeline. So that's how often we're performing computations. So every 5 minutes, we're going to be performing a computation on 15 minutes of data. So that's maybe our longer moving average that we want calculated periodically. Another important part of Kapacitor is understanding Lambda expressions. You'll normally see these in a where clause. Anything that you need to evaluate, Boolean expressions, built-in functions, those are going to need to go in a Lambda block. So in where expressions, the first example would be where host is equal to X. And that needs to get checked periodically and evaluated. And that piece of code there just gets passed directly down, and that's what happens there. Built-in functions, much the same. So when we get all these values in, we're going to take the square root of it. And if that's greater than 5, then we're going to allow it through. So it's just another where condition. And that list of built-in functions is in the documentation for Kapacitor, if you're interested. So here in this stream, you would use the where node to filter according to a Lambda expression. This is an excellent example of that. Maybe you don't want the data for each CPU, you just want the roll-up for each machine. That's more helpful. And then finally, sort of the business end of Kapacitor is the alert node. And that alert node is what you pass your data to after you've decided the amount of data that you want. So down in the alert, we decide what level is this alert, what's the message, and where am I sending it. So we've got a number of different services that are available to send alerts to. They're listed down there. There's also sort of the generic ones like the HTTP, which allows you to just send that message there, CPU usage is level, to an arbitrary endpoint. And that'll go out in JSON. So building servers that accept JSON, not the end of the world. And there's many different things you can do with this. Recently, we've implemented a auto scaling for Docker Swarm, services on top of Docker Swarm using that post functionality. So it's quite flexible. And then if we go through this tick script line by line, we're peeling off our stream of data. We're restricting it even more with a where clause. And then under the alert here, first we're setting the message. If you'll notice here, this is some special syntax. That's Go templating. And in these alerts, there's certain predefined values that you can pass into these templates. There's more information about that in the Kapacitor documentation, but this level is info, warn, or crit. So CPU usage is maybe warn if it's greater than 70. Like if it's 75, then that would be a warn level, and that would be the alert that gets sent out. So there's more information that's available in these templated functions. You can write very customized alerts. So I would encourage you to check out the documentation further on that. And then finally, we're going to post this to a Slack channel. So imagine you have a group of SREs watching Slack channels to see if there's any issues with your infrastructure. Many teams are set up this way. One other thing that Kapacitor does allow you to do is join data. One of the limitations of InfluxQL is that it doesn't allow you to perform cross-measurement joins. Kapacitor does allow for that. So one of the excellent use cases for this would be a continuous query. So maybe you're looking to join two measurements, perform some computation, and then write back to the database, sort of query pre-optimization. This would allow you to do that. So I'm going to walk through this tick script line by line and talk about how a join is performed. So we're going to save two streams in variables here. Var errors is a stream from the measurement errors, and requests is a stream from the measurement requests. So we've taken two little slices of this data stream coming into Kapacitor. We're going to say join requests to errors, and then as specifies the measurement names moving forward in the tick script. Otherwise, Kapacitor will call them things like errors underscore measurements, errors underscore requests. The naming becomes confusing. Make sure you alias with that as after you join. And then we're going to evaluate a function. We need a Lambda expression in there. And then that's errors.value. So that's a field on the errors measurement. That's how you reference that field. And the same thing over in requests. So, and that's an error rate. So once that's evaluated, we're going to call that an error rate. And that's what a join looks like in Kapacitor. Obviously, they can get much more confusing, as you've probably seen joins become confusing in other languages. So this is a great time to take a little second and pause. The exercise here is going to be to write a simple tick script that streams data from the measurement mem and issues a critical alert if the amount of free memory is less than 500 megabytes. I'm going to pause and take a second to let you do that. But before we do that, there is one question from Bulant. Are there any options to monitor over a certain amount of time and then alert once that amount is steady at that level? So I don't quite understand that question. Are you asking for a window of data and then you're looking for a target level to reach, and once that level is reached, alert? If so, yeah, that's definitely, you're definitely able to express that with Kapacitor tick script. Average CPU for 10 seconds and then alert. Yes, that's absolutely supported. That's kind of the normal case for a Kapacitor tick script. No problem. Thank you. So we're going to pause for a second and take a minute to allow you to do this exercise. And again, that's write a simple tick script that streams data from the measurement mem and issues a critical alert if there's less than 500 megabytes of free memory.
Okay, before we look at how to actually do the exercise, we have a question. And the question, Jack, is can you query multiple measurements with conditions like sensor 1 underscore value is greater than X and sensor 2 underscore value is greater than Y?
Yes, I believe so. I mean, it depends on the shape of your data. So normally, if you've got two different types of sensors, those are either going to be modeled as a different measurement, or if they're modeled as the same measurement, they're going to be separated by tags. And using those where filters to separate those tags is definitely doable. Now, that join that we just showed earlier, maybe if the sensor data is in two separate measurements, you peel off each of those little streams that you want, set some conditions for them, join those streams, and then alert on those more complex conditions. So Kapacitor does absolutely support those type of things. Okay, let's go to the completion of the exercise here. So we would have a stream from measurement memory. So we're peeling off that stream. And then our alert condition is going to be critical, Lambda expression, free is greater than 500 million. That's looks like we're missing a 0 there. And then we're going to log that to an alert file. That's one of the other outputs of Kapacitor. You can log these alerts to a file and take any kind of programmatic action you want on them there. Each one of the alerts is just going to be a line of JSON. Does that make sense for everybody? Excellent. Okay, so this section is going to be on using the Kapacitor CLI. So how do you interact with Kapacitor? So defining a task, let's say you have a file called cpualert.tick that contains the below tick script there. You would define that task, so add it to the Kapacitor daemon with the following command: Kapacitor define, and then the name of the task. This is the unique identifier that you will reference it with in Kapacitor itself. Pardon me. That's the unique identifier that you will reference it with in Kapacitor itself. So if you want to show how that task is running, you would run Kapacitor show CPU alert. So important that you name it something consistent. Normally, folks name the file the same thing as the alert. Helps for management. So you also have to tell Kapacitor what type of task this is. This is a stream task. You have to pass it the tick script. So this is the path to the file that we want to run. And then finally, the last argument to Kapacitor define that you need is DBRP. So which database retention policy combo does this particular tick script work on? And then once you have defined that task, if you run Kapacitor list tasks, this is what you would see here. Name, which is the unique ID which you're going to use to reference that task, the type of task, whether it's enabled. So this one's not currently enabled or executing. You do have to take one more step in order to do that. And then which data is this working on? And that's a telegraph autogen. So I mentioned earlier that that's the unique identifier that you use to show information about that task. Here's that command: Kapacitor show CPU alert. So, and this is what the output looks like here. It gives you the name, any errors that are coming from it, the same information that Kapacitor list gives us, the full tick script, and then down in the bottom, this is the output that shows the directed acrylic graph. So in our tick script here, the first node is a stream, and then we pipe that stream into a from. And then the from, we pipe into alert. And that's what the directed acrylic graph looks like. So obviously, if you have joins, many more piping operations, there's going to be more nodes in that. And once you've gone ahead and enabled that CPU alert task, it'll give you more information about how much data is flowing through each of those nodes. And once you enable it, you should see enabled and executing both equal true. One of the other things that you might want to do with Kapacitor is record and replay a stream to test your task. So that would be testing our CPU alert task. And you would do that with the CLI as well. You would say Kapacitor record stream, and then you give it a task. So that defines what data you're recording, how long you want to record it. So that's the full command there. And then once you run that, it's going to give you back this long UUID. That is a recording ID. And then when you list recordings, you should see that pop up. And then in order to replay that recording, you need the recording ID and then the task name. And you would just tell Kapacitor to replay that recording with the task CPU alert. So the exercise here is to define a task off of the following tick script. Bulent asks, can I record for a given time period starting at 11:30 and going for an hour? Sounds like you have some irregular activity happening around midnight. Yeah. I think you might actually have to stay up and trigger that task at that time. There's no way to run that. Well, I guess you could set Kapacitor on a cron, because this is just a command line operation. So yeah, absolutely. Awesome. Cool. Okay, so next, how do we define that task? And this would be memAlert. It's a stream type. We've got that tick script there that we didn't necessarily name, but if we're calling it memAlert, we would probably call the file memalert.tick. And then our DBRP is going to be telegraph autogen. Finally, we're going to do a brief overview of user-defined functions in Kapacitor. UDFs allow you to write your own functions or algorithms and plug them into Kapacitor. You can also build your custom function that runs in its own process, and Kapacitor will deliver data to that via standard in or standard out or another defined protocol, maybe over a Unix socket. That allows you to use any programming language that supports encoding and decoding protocol buffers. So there's protobuf libraries for all of the major programming languages. I think Go and Python are probably most supported, but we're happy to add other languages. And then we're going to have an example here in Python. And this is just a very simple UDF example. Given that you have a UDF that computes a moving average, so we were talking about moving average earlier, within that user-defined function, there's an API for defining what your options are. And then with those options, they can be invoked in a tick script. So that moving average has a property called field, a property called size, and then we're aliasing the data coming out of it there. And this is how you would reference that user-defined function within Kapacitor. There's some more work to be done to obviously write your user-defined function. And then once it's written, there is one step to tell Kapacitor about that and where it is. And that's essentially rewriting some config. It's not an API operation. So there is a bit more involved there. If you want to learn more about this, there's plenty of documentation on our website, docs.influxdata.com, in Kapacitor. So there's a great getting started guide. There's a syntax guide in here. And then there are also some examples within the github.com/influxdata/capacitor repo. There's also an example folder with plenty of other examples there. So finally, we're going to get to questions. There's some subtext involved there. Bulent has one more. Do I have to manually deploy the UDFs? I'm guessing yes. The answer is yes. Obviously, if you're using some sort of automation tooling like a Chef or a Puppet or an Ansible, many folks use that to deploy UDFs, but you do have to get them onto the machine somehow. Yeah. I have seen folks run UDFs containerized and then communicate over Unix sockets on the same host. That's also an option. That opens you up to other levels of automation as well, but again, depends on your deployment environment. Any other questions? I'm also happy to answer questions on any of our other products at this time. And if you have questions after this, please go to community.influxdata.com, sign up and ask some questions. We'll get those answered as soon as we can. And there's also a number of community members on there who are just answering questions. So if I or another InfluxData employee doesn't get to it, somebody else might.